Hi there, welcome back to the breadboard. Today we have another 3D printer build. This time it is the TEVO Black Widow. This kit has been provided to me by GearBest at no cost. I'm going to be showing you how to build this kit. We'll do a review of it, see what pieces may need upgrading, any safety features that need to be considered, set up, etc., etc. See what the first prints are like, and maybe at the end of it have a sort of short chat about how it relates to the build of the Trunksy X5S Core XY printer that we just did in a video a little while back. And now this printer differs in that it is more of a traditional style printer with a build platform that does not move in the Z-axis. Now this one is also a complete kit, the same as the Trunksy X5S was, and it is also based on the Open Builds extrusions, which are V-groove extrusions. I've used them for my CNC builds that I've designed from scratch and shown you in other videos. I like it a lot because it is so easy to get parts. Now, right off the bat, some of the specifications are that it has a build volume of 250 by 300 and a Z height of 400 millimeters. It claims a layer thickness down to 0.05 millimeters, and it can do PLA, ABS, nylon, PETG, wood, PVA, and other flexible filaments as well. It uses the 1.75 millimeter filament and has a 0.4 millimeter nozzle. It's quite a heavy kit, weighs in at around about 13 kilograms, so that's what, 26-30 pounds thereabouts, without getting a calculator out. Comes with an LCD display, SD card reader. It comes with an MKS Gen V 1.3 controller. Now, one of the really nice things about this printer is it is actually a 24 volt power supply printer. The X5S is actually a 12 volt printer, and as you saw with those videos, there were issues hitting any bed temperatures over about 55 degrees C, and it also took a long time to get to those temperatures. Now, I have parts coming to upgrade it to a 24 volt system. That'll be covered in a separate video. In this case, the Black Widow comes out of the box all ready to go with a 24 volt power supply, 24 volt bed, etc., etc. So we should see some significantly improved heat up times and the ability to use ABS right out of the gate, etc., etc. And we will test that when we get to that. First thing we got to do though is we've got to build this. So what I'm going to do is I'm going to unpack all the parts, check them. I'm going to time lapse a lot of this video, and I'll just slow it down when it comes to wanting to make a point of any specific piece of the build. This kit is a dual 110 volts or 240 volts. The power supply probably has a switch in it to select which one. It also, because of that, it's sold the same kit all over the world. Now, when GearBest sent me this, they knew I'm in Canada, so that's 110 volts. They sent me a pack of power adapters. Now, in recent days, this is around January 2018, there's been a lot of videos on the internet, on YouTube, etc., talking about issues with getting electric shocks from 3D printers. One of the reasons why Make and Muse, for instance, had issues with shocks was because of a lack of grounding. He had a lot of extension cords. One of them didn't have a good ground. Because of the nature of how power supplies work, the ground, because it wasn't being grounded, became elevated in volts to sort of like 80 to 100 volts. And this is caused because there was no ground pin on one of the extension cords he was using or something like that. What GearBest did was they sent me one of these 2-pin adapters for the printer so that it can plug into a Canadian socket. No ground, not going to use it. Okay, so right off the bat, that's a no-no. When you buy this, make sure you get a proper North American cable with it, or if you don't, they're very, very cheap. You can pick them up at your local electronics stores for probably about $5 or so. don't use these 2-pin adapters. You want to make sure that that power supply is grounded. Even if all the rest of your printer is plastic or something like that, the power supplies still have metal cases. You still want to have them properly grounded. For filtering and noise and everything else, it relies on having that ground. Using one of these adapters, no good. So we won't be using those. So Black Widow, let's go. So right off the bat, the Black Widow comes with everything in separate sealed boxes. This is the first layer. This one is labeled, what is this one? Main board box. This one is labeled power. This one is labeled extrude. This one is labeled hot end and connecting line is what this one is labeled as. With the Tronxy, the kit was just all piled in and it wasn't really categorized. It was just bags of screws, bags of nuts, spaces, etc. And you had to sort of like filter them all out and sort them yourself. What I've seen of this kit so far is that is not the case. Now you're looking at a few bits of plastic that have been ripped here a bit. That's because I've already checked a couple of things. These were all actually fully sealed within the cellophane when it arrived. So there's pretty much no chance of any screws getting out of the box or anything like that. So let me just pull all of these out of the first layer. We will go through each box in a moment. And then we'll have a look at what's on the second layer. Okay, so got those out of the box. Now the next layer. Very nice big piece of foam here. Very handy. Okay, so we have a full Black Widow assembly manual. Customer satisfaction is our eternal pursuit, so we'll see. How satisfied will I be? Just a reminder, just because GearBest sent me this at no cost does not mean that I'm going to create a review that says everything is wonderful. If I find any crappy pieces, I will tell you. Actual manual. It's all in English and it looks like it has got very clear, very big diagrams, etc. for the assembly. So we'll see. We'll try and follow this. Make note of any deviations as we go. We have a detailed list of all the parts. I'll go through this list offline and just verify everything is there. But it's nicer than to provide a complete bill of materials, which is good. We have a wiring diagram. Now this specifically, this is here because we have an external MOSFET switch for the hotbed. This is quite often done with the controllers that can't handle the power required for a 24-volt heated bed. They keep the controller basically able to work from 12 to 24 volts, and they put this external switch with a big heatsink on it. That's one of the upgrades I'm going to do for the Tronx X5S as well, but separate video. I won't talk about that anymore. But that's part of the wiring that we have to do for this one anyway. So we've got your 24-volt power, we've got a switch, and we've got the hot end. Everything else will be wired normally into the controller. We have a B-layer list for all the parts. I guess we're down at the B layer here now. It's kind of upside down to the box, even though the box opens that way. This is actually laid out like that. So we have all the components here for the B layer, and underneath it there's an A layer, which I guess at the very bottom is where all of your extrusions, your motors and stuff like that are. We've got all of the aluminum machined parts for brackets. These are nice, solid, thick, heavy-duty aluminum anodized. I like red. When I did my CNC machines, I also used red anodized for a lot of the parts. We have standard open build plates for various things. This one is for one of the axes for motor mounts, not for pulleys, etc. So we have a whole bunch of those. Motor mounts, LCD display. We have a controller here. Let's just have a quick look at this. looks like they've already, we will have closer looks of this. They've already pre-wired. All the cables have got labels on them. The nice thing about this one is you've got plenty of expansion capabilities where you can add servos and things like that. So if you wanted to add something like a BL Touch or some other active probe for the bed, you can do that. The other nice thing about this is that the stepper controllers, 1, 2, 3, 4, 5, so that's X, Y, and Z, and then you've got room for 2 extruders. Now we don't have a second extruder, but they've included the motor controller on there anyway. Now the nice thing about that, of course, is if one of these other ones dies, you can always plug that one in. So all the cables are in here. It's got switching regulation for the onboard power supplies, which is nice, instead of linear regulators, so that won't get so hot. USB connection. There is no SD card reader on the main controller card, which means it's probably going to be on the LCD display. This is, looking at it, looks like a standard RepRap discount full graphics smart controller, which has got the full-size SD card reader on the back of it, which means that means when you put this up on a case or something up more user-friendly, accessible, it's easy to get to the SD card reader. Rotary encoder, buzzer. I like to leave the little label on them because then they're not quite so noisy. Emergency stop, and a contrast adjustment for the LCD display. So that's nice. Cables for the LCD display. Various other bits and pieces here shoved into a very nicely formatted foam enclosure for everything. So that just pops out, keeps everything nice and neat. So I'll put that aside. Next layer now, we have all of the extrusions. I'm going to pull this out and just sit it on the table and get rid of the box. That's a bit heavy. Let's just slide that off the back. Pulling out some of these extrusions just to have a look. One of the things with the Trunksy was there was a lot of debris in the extrusions from the machining that they had done. I don't see any debris in these. They look very, very clean. These are 8040 C-beam extrusions. I used these as an upgrade on my CNC machine a couple of years ago. They're really, really nice, very, very sturdy. So for a 3D printer where you don't even have the same kind of loads as a CNC, these are going to work really, really well for keeping a very stiff build frame, I'm hoping. Another C-beam, another C-beam. This is an 80/20, which means it's 80 wide and 20 thick. They're all pre-drilled, all pre-threaded where they need to be. There is no threading on this one because it doesn't need to be threaded. Probably going to be just using T-slot angle brackets and things like that for putting this together. Black anodized. It looks like it's very clean. I haven't seen any scratches on any of it yet, which means they have taken care in packing. And it looks like it's been deburred as well on the edges. I'm just feeling the edges here. I can't feel any burrs from where it was cut with a saw. So they may have taken a little, a quick file to it or something just to clean that out, make it less sharp, which is nice. We have a 40/20. These are all, as you can tell, these are all metric. Another 40/20 black anodized. And the nice thing is, if you ever wanted to get longer pieces or change pieces out for this, you can buy the open builds from the open build store directly, or many other places, very easily. A couple of 80/20 shorter pieces. I think that's for the main bed. We have the MOSFET controller. This allows you to drive the 24-volt bed with ease. There's big MOSFET, big heatsink on here. Keeps the switching off of the controller board, so you don't have to worry about the PCB traces so much. We have a bag of angle brackets. We'll look at these as we go. Actually, let me just pull one out and show you right now. These are for assembling the T-slots. You slide these in the T-slots, screw it up, and these are fairly heavy-duty angle brackets, and they don't take up any of the external space, so they're almost hidden. Allows you to get some rigid joins and things like that. We'll see how well they work. One of the other builds I'm going to be doing in the future, which is a complete from scratch Core XY and more traditional printer build, I use external angle brackets where you can actually see them. They're like a little triangle that fits into the or onto the T-slots rather than into the T-slots. Okay, we now have 3 stepper motors. Now the Tronxy and a lot of other printer builds actually have 4 stepper motors. They have an X, Y, and Z, but the Z axis often is using 2 stepper motors to drive the Z axis. They just put them in parallel from the one controller, and then they just drive both stepper motors to move the bed up and down or the gantry up and down. With this particular printer, they have 1 motor, but they have a belt running between the 2 Acme threads so that it brings the gantry up and down evenly. Now, one of the advantages of this is once you've set it level, you really, unless the belt slips, you really cannot make it unlevel again. I say level, when you tram it to the bed, when you align everything, you want the gantry going up and down, you want it to be trammed level. You want it to be level and trammed to the bed, but you also want the bed trammed to the gantry. So you want it to, it goes up and down nice and smoothly. We'll talk about leveling when we get to it. Anyway, there is an advantage to just having 1 motor because the motors can't get out of sync. So we have 3 motors, and then at the end here we have 2 Acme threads, 8mm trapezoidal threads. So somewhere we'll have one of the other boxes. So these look a bit longer than what we had on the Tronxy. So they look like they're nice and straight. I'm just rolling them together, and I don't see them twisting or anything. So they managed to survive the travel without getting bent. There's something else in here too. Just a few pieces of filler for the front, for the extrusions, just to block them off, maybe put cables behind. They're also slotted in there. So that's the complete kit. So let me just move this heavy duty stuff out of the way a moment. We'll have a quick look at what's in these other boxes. Okay, first up, the power box. Let me just adjust the camera a little bit. Power supply. We've got 4 screws, a warning about setting the correct voltage before you plug it in. And we've got the power supply. This is a 24 volt, 21 amp power supply, S500-24. And we've got a switch. It is currently set to 110 volts. So that is correct for my region. If it wasn't, you would just flip this little switch and that's it. Built-in fan for cooling. Just zoom out a little bit there. And little plate over the connections. And we've got all the connections here for the mains input and also the 24 volt output. Now this one does not have, oh it is, it's built, it's actually very, it's on the aluminum, it's just not easy to see. I'll probably get a piece of highlighter and make that a little clearer. We've got plus V, minus V, ground, neutral, and live. So we've got live, neutral, ground. So 3 terminals for plus V and 3 terminals for minus V. We will make sure the ground does connect to the case, and we will make sure we use a grounded lead. So that looks fine. It's never been open. I won't open. I will actually have an open of this. I don't care if I break the warranty. We will open this up and have a look inside, just to make sure there's no loose bits of metal in there or anything like that. I have had that experience before with this kind of power supply, so it is prudent to check. So that's our power supply. We won't need that for a while. Extruder box. So let's get this open. Ooh, nice. That is a rather unusual hot end, I may say myself. Looks like we have the extruder and the hot end in one. Here's the mount for the hot end. Looks like a standard E3D kind of mount, which is nice, like a J style hot end. It's going to be a 24 volt hot end as well, 0.4 nozzle already mounted. Cooler, I'm not sure if I like the fact that that's quite away from the heatsink here, but it looks like a reasonable heat break. Nice anodized aluminum extruder. That's the hot end. I'm actually quite impressed with that. This is the, it's already got the, this is the extruder motor. The one thing we noticed with this is it's got what is probably a harmonic drive in here. Maybe a 5-to-1 turn ratio or something like that. So for every rotation here, this will do only a fifth of a turn. So you take 5 rotations to get 1 rotation here. What you get there is you get a lot more torque on this filament driving than what you would get from a normal stepper motor. And the idea of that is that you can drive a few more different types of filament that take a little bit more pressure or faster feed rates without stalling. You don't need anywhere near as much power on your motor to get the equivalent torque out of the actual drive end. So that's quite nice. Very interesting that they've used a harmonic drive or something like that on that. I'm not going to take that apart because I don't want to ruin it. But yeah, very nice. That's going to mount directly on the hot end. So that was this is one of the other core key differences between this and, I guess it goes on that side, between this and the X5S, is that the X5S has the filament extrude drive off of the hot end, off of the moving part of the gantry, which means that you can get much better accelerations. This is adding quite a bit of weight to the moving parts on the gantry, which means you won't accelerate as fast. You can still get up to those speeds, it'll just take a little longer. You know, I don't see that necessarily as an issue, to be honest. It just makes it a little more bulky on the hot end, but we'll see how this performs as stock when we build it. I do note that this actual, I'll take a close-up picture of this hob gear. It looks like a very different, more expensively machined hob gear than what I'm used to seeing for extruders. So it'd be interesting to see how well that works. It actually is protruding out of the machined brass piece instead of being hobbed into it with a thread cutter or something like that they use to cut these teeth with. This one is definitely outside of that. Probably makes it a little easier to clean if necessary, or maybe require less cleaning. Okay, what's next? This one, what is this called? Main board box. Unusual name, but okay. Aha, ooh, that's a big fan. Okay, so we've got a flight stick, like a turn on a gunner's fire pin or something type switch here, probably for the main power. Standard IEC socket. So that's the power supply mains wiring here. We've got a cooling fan. So what this came with is a European style plug, which is fine, but really you want to get a proper North American one. Now you look at this and it looks like it just has 2 pins. It actually doesn't. It depends on what kind of socket you're going to plug this into, but a lot of the newer European sockets, actually you can see here there's a metal strip down here and the socket is quite deep, and so by the time these pins are in, the ground is already making contact and you can no longer get to these pins, and the ground is made by a mating piece on the socket that actually connects to this. If you have one of the older style sockets, you can get, although I've never seen them, a piece that goes in here that allows you to put a pin here, or you just change the cable to one that has the 3 pins on. I'm going to be using a different cable that is for North America with a ground pin. We've got belt pulleys, small tool kit. It's a flat blade screwdriver, a sorted set of Allen wrenches, and a stamped little nut wrench spanner, basically. I'm not sure how good. These are not designed for long-term use. They'll probably last long enough to build this kit, but they're not strong. But they're probably good enough because you normally, in a lot of cases, just holding the nut while you use the Allen wrench to tighten up the fitting, whatever you're doing with it. But anyway, we've got a toolkit. So we've got, oh, there's cable ties in here, probably for cable management and also clamping up these belts. We've got brass washers, SD card, and what looks like a thermistor here, probably for the bed. SD card is probably going to have some sample images and things on it. We'll have a look at that later. V-wheels for, this looks like for the bed assembly. There's the springs here. We've got knurled nuts and things for the bed. And we've got assorted spacers and things like that. This is probably for the LCD display and the main control board and things to mount it into this kit. What we have underneath here now is a bunch. Let me just off camera take these apart. Okay, so what we have here is a whole pile, let me zoom out a little bit more, of laser cut acrylic panels that I think make up the case. Most of them are black. There's a couple of red ones here for the sidewalls. They all screw together with this, what is becoming fairly standard, stick your nut in and then screw a screw in to hold it together. If you're not careful, you can crack the acrylic when you do things like that. But we'll use this, we'll build it. The one thing I hate with acrylic is taking the paper off of it. It can sometimes be a real pain in the butt to do, but nevertheless I will take the paper off before we assemble this. So this is for the controller. Everything goes in here. See, this is obviously the back panel with, you got the IEC connection for the mains coming in. Fan there. The red ones have got the TEVO logo on them, etc. So that's all looks like 1/4 inch acrylic, which is nice, except for the two side panels here, which are the red ones. They're just for show, they're not structural. So we will put that back in the box for now. And when we get to that, we'll use it and see how that goes. And the last box here is heat bed and connecting line. So that's this one. So in here, ooh, that's nice. That is the heat bed. Let me just zoom in a little on that. So this is a 300 by 250 heat bed. It has a connector on it for, now a lot of people say they don't like this and it's dangerous. These connectors are not dangerous if they are supported and they don't start coming loose. They're more than capable of carrying the power required. But if you're not comfortable with it, you can unsolder this off of here. And you know, we'll see how we go. Right now I'm going to build it as is, as how it's recommended. If you do end up having to unsolder this and put wires directly on here, I would suggest that you cut off the connector first, as close to this with a pair of fine cutters, and then desolder each individual pin. If you try to desolder all of this and just leave this off, you run the risk of pulling tracks off of the heat bed. So the other nice thing with this heat bed is it has a insulating layer on the bottom, which will help retain the heat, or at least stop you losing heat from the bottom of the bed when you're heating up. Top of the bed has got a, it's not a separate, but it looks like it is a, it says don't touch, but that's when it's hot, it's going to get really hot. It looks like it's already got a build-tack kind of surface on it, so we should be able to print directly onto this, but I would imagine that at some point we will, yeah, it looks like it's stuck on top. We will probably have to put a glass surface or something, because eventually these will wear through and you will have to do a replacement. Although my CEL Robox, this is much smaller printer, much more expensive, but it just has a PEI bed on it and I haven't had to replace that yet, and I've used it quite a lot. So, you know, hopefully this thing will last a long time, but that's a really nice heat bed. 24 volt as well, which is important. A very nice heat bed platform for mounting. Again, anodized aluminum. Mounting holes for the heat bed itself. Mounting holes for the Y gantry mechanics. all of this has got very, very nicely packed. We have a pre-wired cable for the bed with cable chain, which is really nice. Everything labeled again. Yep, everything's labeled there for power, heat bed, thermistor, etc. Not sure whose. Okay, it doesn't have a manufacturer on the cable chain, but it feels nice, the cable chain. So that's nice to see, instead of just having, well, we still do have a little bit of this hard plastic wrap stuff, which I'm not too keen on. A little bit of lighting. I think this is actually for the controller case. Some heavy gauge cable. That was one of the things that I'm probably going to be changing on the Tronxy, is putting heavier gauge cables on for the power side of things. And we got a USB key lead. I think that's everything that's in that box. Yep.